Hi, I'm Veli from Greenwood Solutions. Today's presentation is on solar panels and how much energy they actually produce. So after watching the vid, you'll understand what standard test conditions are in regards to testing the panels, the efficiency of a panel, panel degradation, the cost of electricity and how they're all interrelated. Now if you like what you see, hit the subscription button and let's get stuck into it. One of the most commonly asked questions is how much energy can a solar panel produce over its lifetime? And to attempt to answer this question, we must familiarise ourselves with some basic concepts, such as power versus energy, STC, standard test conditions, and solar panel efficiency and lifespan of the solar panel, and the amount of degradation of the panel over its lifespan, because solar panels do degrade. We have a 5 kilowatt or a 5,000 watt solar array. Its peak power output is 5,000 watts. But due to various factors, this peak is rarely reached. This array, installed in Melbourne, Victoria, Australia, will produce on average 18 kilowatt hours a day of energy, more in summer, less in winter. So, power is instantaneous output based on the capacity of the array. The max power output occurs at solar noon with an equator-facing array on a bright sunny day. And energy is power times time, expressed in kilowatt hours and is related to daytime length, light intensity and other factors. Now standard test conditions, what does that mean? So effectively each panel is tested under a set of conditions. And these set of conditions include that the panel cell temperature, and this is not the ambient temperature, is 25 degrees C. The amount of light is 1,000 watts per square metre, and the air mass index is 1.5, and this is the standard test conditions is what all panels are subjected to before they go out to market. What is solar panel efficiency? Now this is a measure of the amount of solar energy which falls on a panel surface converted into electricity. An average panel conversion efficiency has increased from 15 to 20% in the last few years and has resulted in the power output of a standard sized panel to increase from 250 watts up to 340 watts. And it's related to the standard test conditions. And if the panel has a total surface area of 2 meters squared and is rated at 400 watts, it has an efficiency of 20%. Area of panel is determined and is divided into its watt rating. So 400 divided by 2000 mil, 20%. As there is no moving parts, solar panels are designed to last for many years, but like all things, they degrade. This degradation takes the form of a decrease in production year after year. And nowadays, most reputable manufacturers offer a minimum of 25 years production guarantee. So all panels degrade after the first year, usually in the order of 2 to 3%. And after that, the degradation drops off, but it can be anywhere from 0.7% per year up until 25 years, or down to 0.25, which is the best panel at this point in time that I've been able to find. How much energy is produced is also determined by the location of the solar panel array. For example, in Sydney, the average system, 1 kilowatt will produce 3.9 kilowatt hours. In Melbourne, 3.6, but if you look in Brisbane, it's 4.2. As the array location approaches the equator, optimum tilt angle of array starts to flatten out. You are going to achieve the maximum output from your panels if they face towards the equator. In the southern hemisphere, we talk about north-facing panels, and in the northern hemisphere, you're talking about south-facing panels. We're all set to go with some assumptions, and these assumptions include for every 1 kilowatt of solar installed, we'll produce an average of 3.6 kilowatt hours a day. After first year, all the panels degraded between 2 and 3%. And from year 2 to 25, degradation will vary depending on the panel. And calculations will be made on a range of system sizes. So you can see here, I've got a few columns, and in the first column there's a panel brand, and then you look at the model, and then the degradation after the first year, and the degradation from year 2 to year 25. And we're looking at a range of systems, a 5 kilowatt system, 100, a 200 kilowatt, and 1,000 kilowatt, producing over 25 years. Looking at the 1 megawatt system, best output from panel 1 is at 31,347 megawatt hours over that 25-year period. The worst is panel 10 at 29,563 megawatt hours. This is a difference of 1,904 megawatt hours, or 1,904,000 kilowatt hours. This is over 25 years. So how much is this worth? The answer depends on the average value of each kilowatt hour produced over the 25-year period. In this table, column 1, I have varying prices per kilowatt hour ranging from 25 cents up to 40 cents. And you can see the panel savings on a 1 megawatt system can really vary from, at 25 cents, 445,000 to 40 cents, 713,000. And that's the difference between panel 1 and panel 10. So the most efficient and the least efficient panel. The same applies obviously to a 500 kilowatt system. Obviously, the larger the system, the bigger the differences are going to become when you start looking at a less efficient panel from a panel degradation. The location, the dollar value attached to a kilowatt hour of energy, the tilt angle and direction of the array all play an important role in the final output of the system in addition to the panel's degradation specifications. Other factors include the panel's temperature coefficient, i.e. all panels are temperature sensitive in regards to output and some are better than others. Conclusion, solar panels have become more efficient in the last few years with efficiencies greater than 20%. How much a solar panel produces over its lifetime depends on many factors. On large systems, a solar panel degradation rate can translate into large dollar differences. Thanks so much for watching our presentation on solar panels, how much energy they actually produce. I'm Billy from Greenwood Solutions. If you have any questions, any inquiries, or even any answers, feel free to drop us a line. And if you like what you see, hit that subscription button. See you next time.